let me know they want to be here. I also want to acknowledge at the top, you will see a couple unfamiliar faces here. We have a few guests with us this morning. They are hanging out with us. They're just going to do some pre-calc with us and we can make them, I don't know, ad or something with us. But they're just hanging out. So you can ignore them. Don't feel scared. Feel free to come off mute still. Feel free to like do it up in the chat. I'm here for it. So today is National Pharmacist Day. I know normally it's like National Cookie Day, but today we're actually celebrating like some real humans, which is awesome. So it's National Pharmacist Day. I was excited to learn about this career because I don't know too much about pharmacy. Does anyone have any pharmacists in their family? Any pharmacists in their family? Any pharmacists that we know? Perhaps this time. If so, you can shout them out. It is their national day, pharmacy workers. Someone's brother used to be one. Wow, that's pretty cool. So one, shout out to them because they are essential workers during this time. Really appreciate their dedication. Someone's sister and someone's cousin. Wow, we have a lot of pharmacy connections here. Want to say we appreciate them. Something interesting I found out, Coca-Cola, Pepsi, Dr. Pepper, and ginger ale were all invented by pharmacists. So appreciate that. They make $121,000 a year. That's their median annual income. So pretty interesting. I also learned you have to go to pharmacy school. I didn't know that. Kind of like being a doctor. Totally like being a doctor. There is one US president who used to be a pharmacist before he was president. Does anyone know who it is? Anyone? Someone on that quick Google? Anybody know who it is? Want to take a guess? Emma says no, she has no idea. It was President Humphrey. Yes, Hubert Humphrey. Yes, excellent with the Googles. Appreciate you. Diana and David, did you just know that off the top of your head? No, Google. Yeah, had to search it up, but I appreciate you searching it up. Awesome. So back in the day, he was a pharmacist and worked at his dad was a pharmacist as well. So family trade. So today we're going to jump into assignment 17. Here's our agenda, pretty basic for today, to be honest. We're saying welcome back, Missed Your Faces. Happy to have you. We're going to have our notes today and our assignment for today. We are operating in our new schedule today. Are there any questions about the schedule or like questions about how math works? We've been in a small class for this whole year, so I think we should be pretty much the same. So we're going to keep rocking and rolling. You guys have been doing awesome this whole year. Cool. All right. Feel free to keep messaging me if you have any questions. Since it is our first time back, it's been a hot minute since we have done some notes in this class. You have two options. You have the live action option, which is to stick with me, do the notes with me. You also have the team video option. So if you want to do team video, there is a video posted on Canvas. It is also attached to the notes. It is also attached in the assignment. So you can find that link. It is me doing it in class last year, right? So you'll actually hear the interaction. You might hear some of your senior friends in the background of that call. So you can actually like watch it happen. That means that you might want to do some fast forwarding or some rewinding if you need to. So you have two options. You have live action, you have team video. Any questions about those two options while I open up these breakout rooms? No questions? All right. No, okay. Jonathan had a question. Does this mean pharmacists knew they were putting Coke in the original Coca-Cola? That is a very good question. I do not know if they knew that. Yes. And Janet, thank you for that shout out. I really appreciate you in the chat. All right, I'm gonna go ahead and open up breakout rooms. If you want to watch the video, that would be an appropriate time for you to jump to the breakout room so you have a silent place to watch the video. If you are going to stick around with live action, you're just going to ignore that little bubble. You can move it off the screen. You can exit out of it. If you want to stay with me for live action, you're going to stay with me. Okay. I'm going to go ahead and open up these rooms. Feel free to jump into those rooms if you are doing team video. If you're staying with me, go ahead and send me a direct message, please. Send me a message, or you can tell everyone. Tell me that you're staying with me if you are staying with me, so I know who is staying with me. Thank you, Natalie. Appreciate you. I'm going to go ahead and switch over our screen share here. Thank you, Mia. Thanks for letting me know. Thank you, Caitlin. Thank you, Miriam. Thanks, Devin. Let's switch to my iPad here. So you're either jumping to the breakout room or you are messaging me that you are staying here with me as I switch this over. Oh, I see our screen's a little slow today. Let me know if that screen sharing is having a problem. Awesome. Thank you everyone for messaging me. I appreciate you. All right, there was a new Zoom update for those of you who love to come off mute, which I know is all of you. If you are clicked into the Zoom screen and you press and hold the spacebar, right? If you press and hold the spacebar, it will temporarily unmute you. Yes, Caitlin, I saw you do it. David, I saw you do it. Excellent. If you press and hold that spacebar, it will temporarily unmute you. So you can like press it for a second, say the number or the sentence that you would like to say, and then like unmute yourself. So if that mute button seems hard to find. Alternatively, if it doesn't work for you, you can also just leave your cursor over the mute button and then click and unclick. That's what I do in big meetings. So if you need that, you are more than welcome to use that as well. If you have the Zoom update, you should also have a new reactions button. So that reactions button will let you used to just have like the thumbs up and someone remind me, I don't remember what the other emoji was. But now, yes, David Lopez, now you have a variety of reactions that you can give. So feel free to use those as you need them. You can tell me to go faster or slow down if you need that as well. So you should have a notes page that looks like this. Is there anyone who needs any help locating that notes page? Anything? Feeling good? All right, hearing none for right now, but if you need me, let me know. Okay, cool. Here's what I would like for us to think very simply about. I don't need you to write this all down. If you're taking college style notes and you're just like writing it, you don't need to write down everything. Remember, you're making decisions about what to write down. So think very simply for a moment. If A over C is equal to B over C, then what must be true about A and B? I'm going to read that again. If A over C is equal to B over C, then what must be true about A and B? Emma, can you come off mute and tell us more about that? Emma M.
That they would be equal, because if that means that C and C, they would be the same, so A and B would be equal.
Ah, okay, so if C and C is the same, right, then A and B must be equal. Does anyone want to say that in a different way? So I think exactly, if I know, for example, that C is equal to C, then I'm going to say like, okay, let's call C 3, I'll call 3. And I say that A, I'll call it 1, right? Can I put a 2 here as B? Would these be equal? Is 1/3 equal to 2/3? Golly, quick saying no, right? Right, it's definitely not. What is the only thing that I could put in that B area? Yeah, definitely 1, right? 1 is the only thing. If those two fractions are equal, then the tops must be equal. So our key idea here is if the denominators are the same, then the numerators must also be the same for them to be equal. I know that feels like duh, obviously, but I also want us to like really zone in on that idea because that's the basis of what the hard math that we're gonna do today. The basis is if the denominators are the same, then the numerators must also be the same, right? Must also be the same. So our key process for today is going to be to make the denominators the same. The hint here is to remember my mom and Phyllis, which you may remember from our last session together. Does anybody want to tell the story of my mom and Phyllis, or the general idea of my mom and Phyllis? Mia loved it. Kayla says they want the same thing. Yes. For those of you who might not remember that my mom and her best friend Phyllis live next door to each other, and they, over time, their gardens have been the same. So every time my mom buys a wheelbarrow, Phyllis goes out and buys a wheelbarrow. It all started with a tree in the front yard, right? So they want their yards to look exactly the same. So we have this like somewhat silly story, but it definitely works in this case. So if you are a steps person, you've got the steps here, right? If you are that person that likes to do the same steps every single time, you've got them. We're going to find the LCD, right? We're going to find the lowest common denominator. We're going to multiply by that to eliminate the denominators. We're going to solve it and we're going to check it, right? If you're a steps person, we'll make those things happen. I know a lot of us are free-flowing mathematicians, so you like to just see some examples. So we're going to make that happen. Got a little bit of a lag here. We'll wait for that lag to catch up. If you are currently writing down problems, this is going to be our first example. And I have to tell you, if you remember my mom and Phyllis, we have a new character today. Our new character is Stacy. The same thing, my mom, Phyllis, and Stacy all want the same backyard, right? They all want theirs to be the same. So I need to have a common denominator here. In order to be able to say that these fractions are equivalent to each other, I need to make sure that the denominators are the same, right? I need to make sure the denominators are the same. Galli's already a step ahead of me. What number could I make the denominator in order to make all three of these denominators the same? What number could it be? Three times 6, I've got 3. What big number do I want? I want the denominator to be the same. What big number do I want? Aha, 18, yes, yes, yes. Right, so 18, and I already have some suggestions on how I can make this 18, right? A couple of people are messaging me here. How can I what do I have to multiply 3 times? Wow, hold on one second here. What do I multiply 3 times in order to get to 18?
6.
6, yes, thank you for coming off mute. I've got times 6, and if I do it on the bottom here, what else do I have to do? To keep this even, make this the same fraction. I also have to do it to the top. Thank you, Kayla. So I have 3 times 6 is 18. I've got 4x times 6 would be 24x on the top there. Remember, 4x over 3 is the same as 24x over 18. It's just looking a little bit different. We put a hat on it. We put a 6 over 6 on this. We multiply times 1. All right, same thing. What do we have to multiply 6 times in order to get to that 18?
3.
3, yes, thank you, Mia. 3, right? So I've got 15 over 18, an equivalent fraction. Do I need to multiply anything to the top do I need to multiply anything to our last fraction? No, why not?
Because the denominator is already 18.
Yes, good job. Good job, thank you, Mia. Right, so I have, my denominator is already 18, so I already have 23 here. Now that these have common denominators, I can go ahead and combine them into one fraction. So I'd have 24x plus 15 all over 18 is equal to 23 over 18. And using our big idea, if the first denominator is 18 and the second denominator is 18, what does that mean about the numerator?
They're the same
They're the same. Giselle, how do you know?
because the denominators are both the same and
The
they're equal
denominators.
to 20 over 18.
Yes, for sure. Great job. So if I know that that's true, mathematically, the way that I can show getting rid of the 18 is I can go ahead and say, okay, I'm going to multiply this side by 18, and I'm going to multiply this side by 18. This is how I mathematically write it down. But the idea is that the numerators must be equal to each other. 24x plus 15 equals 23. Like that. Right? 24x plus 15 equals 23. And then from there, I can solve. I'll give you 15 seconds to solve this one. Go ahead and shoot me an answer when you've got it. Galilee's got 3. Can we confirm that Galilee is correct? Three seems high to me, Galilee. Somebody tell me what to do. What's my first step?
Subtract 15 on both sides.
What do I get, Gal?
8.
8 equals 24x. Then what, Galilee?
Divide by 24.
Divide by 24, and we get
0.33. I believe.
0.33. What can I, how can I write that as a fraction?
1/3.
Yes, 1/3. And thank you, Kayla, for the quick chat as well. 1/3, right? So be careful, divide by 24, don't divide by 8. So you should get 1/3 as your answer. All right, if we plug this back in here, we're gonna get 1/3, right? One thing we would wanna be careful of, if we had any variables in our denominators here, we would want to make sure that we're not gonna get any extraneous values, right? We're gonna double check we're not gonna get any extraneous. For now, we're not gonna touch that since there's no variables here, but we will in the next one. Go ahead and privately message me. Tell me if it's a 5, 0. I don't get this at all, miss. What the heck are we doing? 5, I totally get this. Let's move on. 3, I need to see more examples. 2, I'm feeling kind of eh. 4, I'm feeling pretty good. Wow, I got a 6. I love a 6. Cool. Seeing lots of 3s, 4s, 5s. Actually, lots of 4s and 5s. Looking good. Love it. Cool. Let's do another. Let's go ahead and do this one out here. That is a long problem, so I'll give you a second to write that one down. You are doing great this morning. Okay, as you're writing it down, big idea. What do we need to do in order to be able to get rid of these fractions?
Find the common denominator.
Yes, find the common denominator, right? So we need to have a common denominator. In order to do that more easily, right? Is there a strategy that we can pull out of our semester 1 brains? Is there a strategy we can do in order to make one of these denominators less complicated? Factor. Yes, Diana. Thank you, Christine. Thank you, Galilee. We can factor. Go ahead and take this part here. I want you to turn this quadratic into 2 linear terms. 2 linear terms. Thank you, Galilee, for that private message. Thank you, Christine. So we're thinking of 2 numbers that multiply to get 15, add to get 8. I agree with Christine and Galilee. It is +3 and +15. I'm sorry, +3 and +5. Make 15 and 8. So now I have turned this part here. And now we get to think about my mom and Phyllis and Stacy. All right, here is Phyllis. Here is my mom. And here is Stacy. Here are these humans. Who has the most stuff in their yard? Who has the most stuff?
Your mom.
My mom, yes, Mia. So my mom has an X+3. She also has an X+5. My mom is big chillin', right? Like she's like, I went to Home Depot. I bought all the things for my yard, right? Who is jealous?
Phyllis and
Phyllis and also Stacy, right? What does Phyllis want?
an X+3.
Yes, yes, Mia, good. Right, an X+3. And we got to put it on top as well. All right, and then what does Stacy want? What does Stacy want?
An X+5.
An X+5, yes. An X+5. Right, an X+5. I see this idea, right? I see this idea of like X+2, right? If Stacy already has a 3, then couldn't we just give her an X+2, right? Right, like that's the idea. Like, could we just give her an X+2? And my answer is unfortunately no. Whenever they're going to Home Depot or buying something, right? They can only buy that thing. You can only buy a quantity, right? They can only multiply times that quantity. Remember how like if I have 2/3 and I just add 5 to the top and bottom, 2/3 is not the same as 7/8, right? Those two quantities are not equal to each other. If I did 2/3 times 5/5, I would get 10/15, right? 2/3 is the same as 10/15. That works. Multiplication and division will work, but adding a number to the end is not going to work. So that's why we have to do the whole X+5 at the end there. That's a really good idea there. Okay, so now are their denominators the same?
Yes.
Yeah.
Yeah, they are, right? So now I'm just going to deal with the tops here. So 2x times x, 2x squared. 2x times 3 is +6x. I have subtraction here. Remember that subtraction goes into everything that my mom has on top. So I'm going to subtract x squared. The x times the negative x would be, or sorry, the negative times the negative would be a +x, and negative times the -10 will be +10. I'm going to go ahead and abbreviate to LCD. You might remember that we did that just so I don't have to write it down so many times. And then Stacy has 3x plus 15 on my LCD here. Cool. So my LCDs here, now that my denominators are the same, what does that mean about the numerators? They're equal, right? If the denominators are the same, they're equal. So I can multiply both sides. I'm technically multiplying times 3x, x+3 and x+5. That's going to cancel here and cancel with LCD. I have x+3 and x+5. It's going to cancel here and cancel these. That means my numerators are the same. So I would have 2x squared minus x squared is just x squared. 6x and x makes +7x plus 10 is equal to 3x plus 15. How do I solve a quadratic? I see that I have x squared. How do I go about solving this? I'm going to factor them for sure. I need to factor them, but before I factor them, what do I have to have on the other side? Yeah, move over, right? I need to move everything over to one side so that it's equal to 0 so that I can factor. So I'm going to go ahead and subtract 3x. I'm going to subtract 15. That's going to give me x squared plus 4x minus 5 equals 0. Now go ahead and factor. I've got 1 and 5. What kind of 1? What kind of 5? Positive 5 and negative 1. Yes, for sure. What does that mean? The answer is coming out of here. X equals what? Negative 5. And x equals positive 1. Yes, for sure. You guys are doing great in the chat. So these are my two answers, right? Negative 5 and positive 1. I need to double check with my denominators. I need to double check in this denominator. Do I have to cross out any of those equations? I'm sorry, any of those answers? Do I have any extraneous values? Is there anything that x is not allowed to be? Yeah, Christine, could you come off mute if possible? You can type if you need to. Come off mute and talk to us about why you're saying negative 5 cannot be an answer.
When we were learning like last quarter that certain numbers couldn't be the answer, so like the 5 is on like the top equations, meaning that it couldn't like be the answer.
Yeah, definitely. Yeah, exactly. Thank you, Christine. Sorry if I cut you off there. Right, remember how when we were like solving, I'm just gonna write this down here. We were solving these and we were like, okay, if this is in the denominator, right, that means that y is not allowed to be positive 2. Because if I put a 2 in here, right, if this was 2 minus 2, that'd be 0. That would make this whole thing 0, and 5 divided by 0 is undefined. So we're not allowed to have anything on the bottom, right? We're not allowed to have anything on the bottom that's going to end up being 0. So if I take this negative 5 from this problem and I plug it in here, we are going to have, oops, sorry about that. If I take that negative 5 and I plug it in here, we're going to have negative 5 plus 5. That's going to make 0. 2x divided by 0, that's not okay. So this right here, negative 5, is not a solution. An extraneous solution is when you solve it algebraically correct, but when you plug it back in, it creates a non-answer. It creates an undefined situation. Is 1 an okay solution, or is it also extraneous?
It's okay.
Yeah, it's okay. Why is it okay, Mia?
Because no matter which one you plug it into, the answer won't be 0. You'll still have a number.
Yeah, definitely. You'll have 1 plus 5, that's 6. We have 1 plus 3, that's 4. So both of those things are totally fine. So this problem has, it came up to 2 solutions, but one of them is extraneous and does not count. So we would say that the only solution to this problem is x equals 1. X equals 1. That is the only answer to this problem here. Okay. All right. Give me a fist of 5. Where are we at on this problem? It was much more complicated than our last one. Fist of 5, 0, I don't get it. 5, I get it. Cool. Cool. Thank you for your honesty, everyone. Awesome. Feeling it. Chat blowing up. Cool. Okay. Seeing where we're at and how we're feeling, I'm going to go ahead and have us skip this third problem, because you can watch that third problem in the video if you want. I do want to go over this problem here. You can also watch this other one in the video. So if you're feeling super good and you want to jump to the assignment, feel free. But I do want to go over this one since it has this whole number here, right? This whole number. So we've got Phyllis. We've got my mom. What is my mom's denominator? This one too.
1.
1. Yeah, for sure. Thank you, Gali. Thank you, Christine. So 2 over 1. I'm gonna just write that over 1 so I don't forget. And then we've got Stacy over here. Is anyone fully satisfied at this moment? Like everyone has what everyone else has? No, no one, right? So we know that Phyllis has a y minus 2. Everybody else is gonna want that as well. So I'm gonna say, okay, y minus 2 is going over here, and y minus 2. And then, wow, give it a second. It is super duper laggy. Okay, so now everybody has a y minus 2. Phyllis, Mom, Stacy. Does everyone have a 1?
Yes.
Yeah, right? Like everyone has a 1. It's just like kind of, it's like sort of just hanging out there, right? Everybody has a 1. And then the 6 has a 1 in it, right? So there's an imaginary 1 here. We can put that there. The 6 is like 6 times 1, right? So Stacy already has a 1 in there. We could multiply times 1 if we want, but it's not going to change our problem. All right, so now everyone has a 1. Everyone has a y minus 2. Does everyone have a 6? No, not everyone has a 6, right? Only Stacy has a 6. So I'm going to go ahead and multiply times 6 for each of these. So now everyone has a 6. So my common denominator is 6 times 1, which would just be 6, and then 6 times y minus 2. So that is my common denominator. I need to figure out what my numerators are. So I have 6 times y minus 2. It's going to be the denominator on both sides. So now I have 6 times 5, 30, plus this is going to be 12. 6 times 2 would be 12. And then the 12 is going to get distributed into the y minus 2. So I'd have 12 times y is 12y. And then 12 times negative 2 would be negative 24. If you want to write that out in more steps, you're welcome to. I chose not to at this moment. Then I have Stacy, 17 times y, 17y. 17 times negative 2, negative 34. If my denominators are the same, what does that mean about my numerators? They're equal to each other. So I can multiply both sides times 6 times y minus 2, cancel, cancel. 6, y minus 2, cancel, cancel. And I have, I'm going to simplify this. 30 minus 24 would be 6 plus 12y is equal to 17y minus 34. I don't have a quadratic, I just have a linear equation here. So I'm just going to move things around. So I'm going to subtract 12y. At the same time, I'm going to add 34. I get 40 equals 5y. What does y equal? 8. Yes, 8. Y equals 8. Is that an extraneous value? No. Where is the 24? Good question. I did 30 minus 24 to get that 6 right there. So I combined 30 and 24 to get 6. Is 8 a okay solution or is it extraneous? It is okay. Yeah. What would be the answer if we got that answer that it would be extraneous? Positive 2. Yeah, positive 2 would make this value extraneous. What if we got 6? Would 6 be okay? Yeah, 6 would also be okay. because this 6 right here, if I plug in a 6 here, 6 minus 2, that'd be 4. I'm not going to plug in a 6 anywhere else. I'm only going to plug it in for a y. So a 6 would be okay. The only thing that would not be okay is a positive 2, because 2 minus 2 would make 0. That would make the denominator 0. Okay. What if it was negative 6? If I plugged in negative 6 here, negative 6 minus 2, that would give me negative 8. That's an okay denominator. So negative 6 would be okay. Also negative 2. Negative 2 minus 2 would be negative 4. That would be okay as well. So the only thing would be to plug in the positive number 2 here. So positive 2, that would be extraneous. You could, at the beginning, you could say, you could look at this denominator, right? Like at this step here, and you could say, okay, the extraneous y is not allowed to be positive 2, according to these denominators, right? So what if I get y equals 2, I'm going to know that this would be extraneous, right? So I want to not have positive 2, but 8 is a possible solution. So 8 is my solution here. Okay. All right. So those were our 3 examples for today. For your assignment today, let's wait for it to get there. You're going to drop in your notes. So you have your notes here. And then you are choosing 9 out of these 10 problems here, right? And you should have your answers here. Please let me know if you're getting something that's not there, so I can update the answer key. You have an optional challenge, right? Optional meaning extra credit, or like you don't have to, but I would love to see what you try if you try anything. And then you have a baby feedback section here, right? Baby feedback section. So really, like if you're just trying to get out of here, you're just posting your notes and then you're doing 9 problems, right? So you're posting your notes, you're doing 9 problems. I don't really have the new schedule memorized yet, and I know it's somewhat different for everyone. Do you all have Spanish next, or do you have time off until Spanish? Or is it a mixture? Gally has time off. Layla has Spanish. Time off. Spanish. Spanish at 10:35. Oh, okay. So we're like split still. You have your normal Spanish times, is that true? Okay. David, did that change for you? Were you at 10:35 and now you're at 11:20? Or have you always had Spanish at 11:20? It stayed the same. Okay. So it changed for you, Gally. Okay, interesting. Okay, if you want to keep working here, I can hang out for about 10 extra minutes. If you have to go to Spanish at 10:35, feel free to jump off. This is the end of our official class today. We do not have official office hours, so please do let me know if you have any questions or things that you're thinking about, and I'm happy to jump on a call with you if you need like distinct help, or I can help you on a specific class if you want. So just shoot me a message and we can work it out. I'm going to end our recording. Bye, recording.